Okay, so welcome back. Today we are going to show you how in C# to convert numbers from one base to another base. And ultimately we're going to develop the simple application here that allows you can see on the left, it allows you to convert a binary number or an octal number or a hex number to an integer. And on the right hand side we can convert an integer to any one of those binary, octal, or hexadecimal numbers. We'll start out, we've got this radio button where we can select either we want to change a binary or an octal or a hexadecimal to integer. We'll start out with the binary and we'll put 101, press the button, convert to integer, and that's a 5. And you can see that makes sense because the binary digits have a weight of 1, 2, and 4 plus 1 is 5. We can do the same for the octal. We can say octal number of 2, 3, and that's a 19. And hexadecimal, we can say F6, and that's a 245. And over on this side, we can punch in 245 and convert that, and you can see, yes, it's an F5 in hex, it's a 365 in octal, and 11110 in binary. So now let's take a look at the difference between integer, binary, octal, and hexadecimal. As you probably know, integer and decimal numbers are things that we're very familiar with. For example, we might have 935,620. We can work with that, it makes sense. And that's what's called a base 10. And what that means is each digit in this number can have only one of 10 possible values. And those values go from 0 to 9. Keep in mind, 0 is a number. So 0 through 9 gives you 10 possible values. Because if we go to 10, that's 2 digits. That's not 1 digit. Now, the computer works on what's called binary, ones and zeros. And the reason it does that is because that represents actual voltage, switching voltage on and off to your electronic components, and it only knows ones and zeros. So we're going to have to convert everything ultimately in the computer to ones and zeros. And that's called binary. And the reason it's called binary is bi means 2. And that binary is a base 2, which means there's only 2 possible values for each digit, 0 or 1. And that represents on the computer a voltage going from 0 to 1. And here is a typical binary number with zeros and ones. So base 2, only 2 possible values. And then there's octal. We humans don't really like working on binary because it's just a bunch of ones and zeros, doesn't make a lot of sense. Octal is another way to represent the same number or different numbers. And that octal is a base 8. That's what octal means. And that means there's only 8 possible values for each digit. And those values are from 0 to 7. And that's why it's called base 8, because 0 to 7 gives you 8 possible values. Again, 0 is a number, so it's counted. And then the last one that we tend to use more often when we get down into the hardware realm, is called hexadecimal. Hex means 16, so it's a base 16, which means only 16 possible values for each digit. And those values can go between 0 and 9 and A through F. The total number of possible values is 10 plus 6, which is a total of 16 possible values. So in C#, Visual Studio, Windows Forms, there is a class called the convert class. And that's what we're going to use to convert all of these different values to other bases. So for example, let's say I have a binary number and it's a string of ones and zeros. And I want to take that binary number and convert it to something that's more meaningful, which is an integer. So there is a convert class in C# where I can convert this string of ones and zeros into an integer. And to do that, I use the convert class, the toInt32, and I can feed it this string of ones and zeros. However, I have to tell it, hey, this string of ones and zeros represents a binary number. To do that, one of the parameters is the input string, these ones and zeros, comma 2, which means it is a base 2 number that the string represents. So I'm feeding it ones and zeros in a string. I'm telling it, hey, that's a base 2 number. Convert that to int32, and it will return the integer version of this ones and zeros. Same thing with an octal. If I feed it a string representing an octal number, I feed it the string, but I have to say comma 8, which means it's a base 8 or octal number, and it will convert that to an int32 value. Same thing with hexadecimal. I feed it a string of hex values, AF32C7. I feed it the string comma 16, which tells it this is a base 16 number that this string represents. Convert that to int32. And as a result, it will take this binary number and convert it to 1489, which is the integer equivalent of this binary number. Same thing with the octal. It will convert that 127241 to a 42657. And with the hexadecimal, convert this AF32C7 to 11481799. So nice way to convert any string of any base number into an integer that we can use. Now you can go the other way. So for example, you can take an integer number and convert it to a string that represents that number in those different bases. And again, we use the convert class, but instead of convert to int32, we are now converting to string. And we feed it the integer string and tell it, hey, convert that to a binary. So we do comma 2. So we're converting that into a binary. It gives us this 11000 number, and it's converting that number into binary. Same thing with octal. I feed it the same number as a string, comma, hey, this is an octal number. Convert that to a string, and it will convert that into an octal version of this 12536. And same with hexadecimal. Convert it to a string. I'm giving the input integer as a string, and it comes out with the hex version, which is 30F8. So now let's see how we can implement this in C# Visual Studio Windows Forms. Now, before we get into the code, you can imagine we've got some radio buttons. These are inside a panel. I've got a bunch of text boxes to represent the different bases, and then I've got the resulting integer as a text box. I've got a button for the conversion, and then the other way I've got more text boxes and some labels that label the results of the conversion. So let's take a look at the C# Visual Studio Windows Forms application. So here's my application, the Form 1 design. We're not going to go through that in detail. Again, I've got a panel, some radio buttons, some text boxes, a convert to integer, and that's about it. In the Form 1, I've got methods and I've got event handlers as I normally do. We've got System Windows Forms. When I initialize the Form 1, I say this radio button for the binary is checked as true, and that's basically just defaulting this to be checked. And then the methods and event handlers do the actual work. Now, the event handlers, there's basically two event handlers. One converting to an integer, and the other on the right-hand side converting from an integer to the three other bases. Now, I'm also going to do some error checking. When people enter data into this text box, I want to check to make sure, hey, if they're entering a binary number, make sure it's just ones and zeros. If it's an octal, it's only a number between 0 and 7, hex, so on. So we do some checking, and I've got some methods here for each to do some checking. But basically, the two buttons are what initiate the conversion. So the methods are check binary input. Basically, it takes the string from that text box where the user enters a binary number and says, hey, are these just ones or zeros? Same for octal and same for hex. We won't go through those in detail. So for example, if I punched in 1F as a binary and I try and convert it, it's going to say, hey, wait a minute, you got bad input data. That should be a 1 or 0, not an F. And then I can delete that and convert, and it will convert it successfully. So when I do that button click to convert to an integer, we're going to default that label text to null and then check to see if it's bad data, and if it is bad data, we'll display an error message. But basically, I've got three if statements. If the binary input radio button is checked, then it does this. If the octal radio button is checked, it will convert the octal to integer, and same with hexadecimal, it will convert the hex to integer. And so these are all pretty much identical. if radio binary dot checked, and I want to convert the binary, I'm defaulting a bool of bad data, and I'm saying input string, the binary input string is that text binary dot text, and then I'm going to call that check binary input, feed it that string from the text box, and if this is bad data, this is going to be true, and we can print the error message. Now, if bad data equals false, I'm going to use that convert class that we talked about and said, hey, take that input string, which represents a binary number, and we're using comma 2, which says, hey, this represents a binary number, convert it to an int32, and that's going to be our int val2. And then we will take that resulting integer and put it in int val2.string to the text int out.text. So it's basically taking that binary and putting it into this text box. And the same for all the others. If bad data is true, it's going to print that bad data input. Same thing with the octal input. If we input an octal number, bool bad data, string input oct string is whatever in that text box. And then we're going to check to make sure it's octal input, which means each digit is between 0 and 7. If it's not bad data, then we're going to do, again, the convert to int32, that string, comma 8. So that's the only difference. And same thing for hexadecimal, convert to int32, the hex string, comma 16. Now for the other one, where we're taking an integer and converting it to those different bases, it's a whole lot easier. We're taking whatever's in that input text box, this integer text box right here, and we are converting that to an int using int.parse, and that's giving us our integer to convert. And then all we have to do is use that convert class, but use convert.toString, and we're going to assume that the number is correct, that it's a correct integer. We're not going to do any error checking. And then we're going to say the int to convert, and we want to convert it to a base 2 or a binary, and that's going to give us a string with a binary representation of that integer. Same thing for the octal and same thing for the hexadecimal. So really pretty straightforward. You just use the convert class, and again, this does a whole lot of stuff. You can convert it to many different formats, but this will give you an idea of you can start looking into the convert class to do whatever conversion you need. So that's it for this one. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.